Hi folks, my name is Maxwell Nkomanga, and today I would like to share with you one of my experience on the CIGIAR dataset modeling crop images issue, and we'll give an AWS SageMaker perspective of the solution. So in the agenda, we will have an introduction, and we will present at the second point the eyes on the ground challenge problem. I will give the methodology of the solution, and also we will provide our solution on AWS SageMaker for training the model. So at first, in introduction, the goal is to train machine learning algorithm to evaluate thousands of farm images by verifying whether the farmer's crop are damaged, and then to provide agricultural advisories. So we are evaluating the risk of damages of crops on farms and see how we can personalize agriculture. So the second objective will be to build a machine learning model to assess crop images using Amazon SageMaker service. And also we will share the gain experience in the challenge with the community. So the data set is coming from the ACRI program. So this ACRI program is launched on the platform Zindi that you have there, the page project, zindi.africa. So this data set consists of more than 26K of images of crops, land, which relate the status of the plant. So one of the characteristics of this dataset is very imbalanced and has similar images in different categories. So this makes it complex to model. So our methodologies will be to collect different images of different crop categories to train a model to discriminate or partition images with the triple loss learning as cost. We'll describe what is triple loss learning. It is metric of classification to improve images which are very similar in terms of characteristic or representation. So we generate embeddings for each partition from reduced dimension, and we apply a cluster classification based on cosine metric. So as stated before in the present slide, the triple loss learning is a process for similar images on different classes to train and find how we can close images which are very similar and take away images which are not similar. So as you have there, you have the anchor images of the given category class, and we have the negative class, and we have the positive one, which is far, as you see. By applying the triple loss, we see that the images which are very similar in terms of representation or characteristic will be closed, and the negative images will be set out. So this is triple loss learning. So it is a based learning algorithm, a distance-based learning algorithm, which permit to classify embeddings of images or representation of images. So this is the design of our solution. So we have there the raw images labeled by DR, D as good quality of farm, drought or nutrient deficient, weed, and other categories, which is disease or pest or winded. So those images have some transformation at first. We make some kind of image augmentation, vertical flipping, horizontal brightness or color, and it will be transferred. Those images will be cast on 1990 pixels for a deep learning model architecture to gain the feature representation of this image using the MobileNet deep learning architecture. This MobileNet is given by this link as project. But when having the first features generated by the MobileNet, we use them to train the triple learning loss algorithm. So by applying it, we generate the embeddings of the image. It is a vector of 129 dimension. So we have set it to 129 according to the paper. And we apply the loss function. the given loss, triple loss function. So if the loss is low, so it is good. So we can proceed by a 5NN classification, cosine metric base, 5 as we have 5 categories. And if it's not good, we are repeating the training loop. Okay, so let's give a try with SageMaker to see how all of this is going and how we can train the embeddings of the crop images. So this is my Amazon console. So I share it with you. Then I've already logged in. So for the first time, for those of you who are still who are opening it, you will have to search the Amazon SageMaker service. You can type it in the searching field as SageMaker. So then you click on it. I already have it, and you can open it. But before that, we also have an S3 bucket. The S3 bucket is the storage service of Amazon where you can put the data. So let us open it. Okay, nice. So we have created a bucket entitled CIGIAR crop, and Amazon has many regions, right? So for this, we put it on the US East one region to save information of training and the test data. So we have the best model path, which gather the model that we train. We have the folder of images. We have the train representation and the test. Now the train CSV file, which contains the summarizing of information on the training data and is corollary the test data. So when you have pushed it, you can push other information if you want regarding how you require inputs for the projects, thereby uploading them. So we go on SageMaker to see our solution. So when you open SageMaker, you will have at your left side the notebook section. So you open the notebook instances, and this one is named CIGIAR Notebook. So CIGIAR Notebook, and we took machine learning T3X large. So there are many kind of, keep in mind that each notebook is running on Elastic Compute, an EC2 instance, and you have MLT3 extra large is a kind of EC2 where the notebook is saved. And you have many kind of, if you want more information about those instances, here we are. The notebook available instances, EC2 instances, you have MLT3 medium, large, extra large. We have 16 gigabyte there for extra large, and you can also change it regarding how you proceed. So you open the notebook instance. Okay. So we have the information of our notebook, which are represented there. And you click on Open Jupyter or Open Jupyter Lab. I've already opened it, so you go there. So you have something like that. You can create a new Jupyter project based on PyTorch or TensorFlow 1. They have already been created. So the project is there, CIGIAR Eyes Underground Challenge that we open. Okay. Yes, here we are. We import some libraries. The TensorFlow TF, because we use here TensorFlow instead of PyTorch for the project. You have the TensorFlow Hub is a kind of library for transfer learning. So we are fine-tuning some model to train our data. So by using TensorFlow Hub, it gives you the possibility to embed an existing deep learning architecture. Import some library, we set the seed for reproducing the computation in the GPU's information. So here we are importing our data that we have shown before on the S3 bucket in the CIGIAR crop. So we are loading the training data, create a session. Yes, you have taken uh, the default role accorded by the extra S3 service of Amazon. So we import it. The key is train.csv. We import the test data. Yes. And here is some kind of distribution there we are displaying. So good images are high, some draft images, and yes. So from this chart, we observe that the damage categories are imbalanced and zero flattened. So you can look at the classes order and D. So a particular attention is paid that the loss function reduce the interval variability and maximize interval variability. So we want to have a model which can learn about this kind of distribution. We will not use some technique of imbalancing, augmentation, something like that to give them same size distribution classes or average. But what we will do, we will try to generate some kind of embedding. So we will give the representation of a given class or category of images in another in another dimension space, like 129 feature that we presented in the slide before. And we want to improve the intra-class variability. So a group of images in which variance approaches is very less. And we want to increase the variability in the sense that categories which are different are very far away. They are not close. Okay, so here there is a strip that has been given by the challenges, the Zindi platform. So you can have it there. This is the Zindi platform there. You have the information about the problem challenge. It is there, and the link of the file to download there. I think it is, yes, it is there. This is the page of project Zindi Africa slash .Africa slash competition. Okay. So by going there, you will download the data of the project. With this data first was embedded on an S3 Amazon S3 bucket named CIGIAR crop damage classification. So you get it and you store it. We apply some kind of preprocessing to have the images. Here we are loading the data on TensorFlow. This is one kind of first image check. And then we create a data set. So for the mobile net version 2, we need to provide the shape of the images to 96 frame. So we give it as input. We are applying some kind of image preprocessing step, and we map it to all the training data. And then here, this function get XY from DS permit us to generate a kind of NumP representation of the data set to train. And then we extract some images from visualization. So those function has been given there, but we are not visualizing it right now because it is a bit consuming time. And yes, the IP widgets also permit us to visualize those images. So I will insist much more on the training loop. So the training loop, we define first what is the batch, how we organize the data. So as you recall, in the triple loss based learning, you will have three kind of three group of images in one category. So you will take the category and you will give the anchor you will give the similar images and you give the images which are not from the category to train them. So this is what is done by this function. It is trying to give a batch of embedding of not embedding, a batch of those triplet representation. So we are generating the triplet there to have information to train. So we are training triplets. So here is the model architecture that we have. So in the mobile net version, mobile net deep learning architecture that we are embedding. Okay, so some random flip is applied, some random rotation, and some dense layer is applied to the model. And here is the structure. Okay, so we will not implement this triple loss function. It is given by a library TensorFlow add-ons that is already given. It is still available right now, I think, so that you can install this library and use it. Yes, as hyperparameters, we define the batch size, the epoch, and the patience. So the patience there is a number of time that we should wait when the learning rate is not moving. So we should wait a certain period of time. If we observe that in this time the learning rate has improved, so we decrease it. And the learning rate size there is the initial value, learning rate, yes. Yeah. So there we define the logger, the information about the training log and the path of the model where they are safe. And yes, we are using cross-validation, so some kind of scaffold to find the best model optimized, the best optimization model to use. And here, this is our training loop. Yes, we have this training loop there, which train the triplet generated by the algorithm before. So we have defined the structure of our model, we compile it, we are given the configuration of the optimizer, which is Adam, and also the learning rate, and also the triple loss, as you see this function which will be used to discriminate the triplets that are provided, and then the training is started. So quietly, this process can take 5 hours when running normally. So because it is more than 26,000, 26K images, it is a bit easy. So for the first training fault, we are saying that this model is improved, is very good there. So the score there it is at 0.3. And the validation error and the training error there seems there's very close. Yeah. And for the second batch, yes, the error is still decreasing, but now we are 0.25. So the model is still improving there. Yes, and the same thing for the fault 3 batch. Yes. Yes. So, and for the fault 4 of the cross validation, we have 0.26. So as we see there, the best configuration for all is to use. And keep in mind that this algorithm keeps the best model score. As you are seeing there in these photos, view the lines, line number, as you are seeing them from the line 34. So we are keeping the best model score. This is one which is saved in our S3 buckets. Yes, yes, it is saved there in the best model path. Yes, and so for this model, the best one was the best one was 0.25. So it is for fold 3. Yes. So guys, this is what I wanted to share with you. First, how we can apply paperless learning to model coping farms images. And this algorithm is very nice because it gives good results, as we have not we have the facility now to classify at the end by applying a 5 or KNN algorithm just by computing the distance. So we can keep the embedding on the dictionary and just compare the embedding generated for an instance images with the closest cluster embedding to have this category. So yes, guys, stay tuned and we'll try to share more things like this for next time. So have a good try.